This configuration represents a prototype 4061, both hardware and firmware. The basic hardware of a 4061, basic display hardware, consists of two sets of frame buffers or graphic memory planes superimposed upon each other. One of them we call the dialog plane, and it is used primarily for alphanumeric interaction with the system. The other set of frame buffers is termed the graphic frame buffer set, and it's used for drawing vectors, graphical text, area fill. Primarily today we're going to concentrate on the dialog plane. You'll not actually see the superposition of the two planes in action. We'll reserve that for a later segment. The program that we're looking at today is a prototype designed to verify the performance of the microcoded display controller in the alphanumeric area. It is not really a bona fide user interface exercise, although many of the ideas that we'll be exploring today could in fact be used in a user interface, a production user interface. What you see on the screen now is 5 windows. Each window is effectively a rectangular box area. I'm moving the cursor around the edge of one of them right now. What I'm going to do is cycle through these briefly. This crosshair cursor moves to the center of each window in turn every time I strike a key. The paradigm here is shuffling pages of paper on your desk. We're just doing it on a CRT. What happens every time I press one of these keys is the entire dialog frame buffer is erased and all 5 windows are redrawn from back to front in the correct order. Now let's zoom in a little bit on this window. What we're looking at in this particular case is a piece of code. It's written in a language called TSL, which was our systems language for the 4061. To some extent you're looking at a self-portrait of this program. This is actually a fragment of the program that we're using to run this demonstration. Since I have selected this window, the trackball and the keyboard are now connected to it. One of the things I'd like to show you is the fact that I can scroll vertically and horizontally, looking at the text in this window. Vertically, we're employing what we call Hollywood scroll. Very smooth. Essentially what's happening is I'm rolling the trackball with a shift key. That motion is being translated directly into movement of the text on the screen. You'll notice that the horizontal scrolling is not nearly as smooth. That's because we're scrolling 20 pixels at a time, due primarily to the implementation of the frame buffer as 2016K RAMs. Now if we zoom back a bit and show the entire screen, you'll notice that I can also select windows by pointing at them with the cursor and then pressing a key. Basically it puts the window that I pointed at on top and connects the keyboard and the trackball to it. Now these two windows here contain the same textual information. Let's zoom in a little bit on this top one now. What it really is just a memo. What I'd like to show you are some of the characteristics of the text itself, or the way we display the text. This is a standard 7:9 dot matrix font. very similar to what you'd see on a conventional word processing system. We're using constant pitch characters, which means that every single character occupies the same amount of space horizontally, independent of which character it is. I'd like you to take a look at this word spelling here at the top of the cursor. You'll notice that even these very narrow characters occupy the same width as some of these larger characters. Well, let's drop down to the window below. I'll select that window now to put it on top. And if you take a close look at the word spelling here, you'll notice that it looks somewhat more like the text you see in books or magazines. That's because we're using a variable pitch technique. Each character width is proportional to its actual visible width. So the L's and the I's here are much narrower than the capital D's over here. One of the things we were trying to explore in this system was what the impact would be of implementing a fully general variable pitch algorithm within the display controller. As we move on a little bit later, you'll see that we in fact can even type from the keyboard in variable pitch. I'm going to select a blank window now, and I'm going to quickly print out what I call a sampler. I'm going to scroll back to the top now, and you'll notice that we can embed within the text reverse video changes, font changes, and character spacing changes. Each attribute, such as font, text spacing, variable pitch, and reverse video, can be independently controlled and changed from character to character, word to word, line to line. Down here at the bottom is a large block of text that's in reverse video. You'll notice as I scroll up and down that some rather odd things are happening at the base. That's because the way we actually scroll in this system is by moving the bits within the rectangular area and then writing the small amount of text that's filled in at the bottom. The process of moving those bits causes the bottom of the frame buffer to be zeroed, which of course shows up as black as opposed to the white background if we're in reverse video. Now I'm going to show you some of the characteristics of the line editor. If we zoom in on the top area of the screen up here, the top area of this window, over here, yes, I'll just type a line of text. You'll notice that as I typed off the right edge of the window, the text scrolled left horizontally to match it. You'll notice that there's a little blinking cursor. We call that the alphanumeric cursor to distinguish it from this graphic cursor which I've been moving around. What I'm now doing is moving the cursor left back along the text. You'll notice that I can move it left and right, one character at a time. I can also move it left and right, one word at a time. I'm going to go right back to the left-hand margin now. Basically, what this kind of cursor allows us to do is to replace characters. For instance, if I replace the lowercase t with an uppercase T, you'll notice it moves over to the H. I can capitalize the first letter of each word. It's probably become apparent to you by now that I'm typing in variable pitch. When I replace a lowercase g with an uppercase G, things adjust ever so slightly because an uppercase letter is typically a little bit wider than a lowercase letter. Well, one of the other things that we can do with a line editor is to change the shape of the cursor. You'll notice that every time I press this key, it toggles back and forth between replace mode, which is this underbar, and insert mode, which is this vertical bar. Now, if I were to type here, instead of replacing, we wind up inserting. Of course, I can move this cursor left and right, character at a time, and word at a time, just as I can with the other one. Well, I can delete the same way, left and right, character, and word. Okay? The last thing I'd like to show you is now if we zoom back, you'll notice that I've essentially toggled the reverse video of the entire system. We're now typing black characters on a white background as opposed to white characters on a black background. This was a bit of an experiment on our part just to see whether it seemed more natural to people who are accustomed to working with typewriters.